You ever watch your favorite show and have that little voice in your head go, wait a minute, could that actually happen? Well, today, that's exactly what we're going to do. We're going to put that question right under the microscope and explore that awesome space where science and pure imagination collide.
These are the kinds of wild questions that only fiction can make us ask, right? How do you actually make gravity work when you're floating in the middle of nowhere? What would really happen if you tried to shrink a person down to the size of a kid? It turns out digging into the science, or the lack of it, is even more interesting than you might think.
And just to be super clear, we are not here to be killjoys. This isn't about debunking the magic. Think of this as a grand thought experiment. We're using the laws of our own universe, like a ruler, to see just how these stories work. We're going to find out where the science is plausible, where it gets stretched, and where it becomes something else entirely, a powerful metaphor. Okay, so let's kick things off with what might be one of the most scientifically solid settings in all of fiction, the Universal Century of Mobile Suit Gundam. We're going to see how they tackled the massive problem of building a real home out among the stars. So, you're out in the total void of space. Zero gravity. You can't just build a city and expect people to walk around normally. The solution Gundam came up with is a giant spinning cylinder. And get this, that's not just sci-fi hand-waving, it's a real-world concept called an O'Neill cylinder, designed to create artificial gravity using centrifugal force. You know, that same force that pushes you outwards when you're on a fast spinning ride at the fair. And here's the part that just blows my mind. The math actually checks out. For a colony with a diameter of 6.4 kilometers, you'd need it to make one full rotation every 113.5 seconds. If you hit that exact speed, the force pushing against the inner surface would create artificial gravity almost identical to what we feel on Earth. It's not magic, it's just pure physics. And really, it all boils down to this one beautiful equation, the kind of thing you'd see in a high school physics class. The entire idea of a livable home in space for millions of people hinges right on this simple principle. Spin something big enough, fast enough, and you can make it feel just like home. But living in a giant spinning can would have some pretty weird side effects. See, because your entire world is constantly rotating under you, anything that should move in a straight line will look like it's curving. That's the Coriolis force. So if you threw a baseball straight up into the air, it wouldn't come straight back down. It'd be a constant, trippy reminder that you are definitely not on a planet anymore. And that is exactly what makes the world of Gundam feel so real. Its creators built their world on fundamental physics. They didn't just invent some magic anti-gravity machine. Nope, they used real-world mechanics to solve a real-world problem. And because of that, their world is so much more believable. All right, let's do a complete 180 now. We're jumping from the totally plausible to something that just shatters the laws of biology as we know them. Let's talk about the very strange case of Detective Conan. Okay, so the whole story kicks off because of this mysterious poison, APTX 4869. Most of the time it's lethal, but every once in a while it causes this bizarre side effect. The victim's body shrinks all the way back to a child's, and that one simple idea for a story, it opens up a massive can of scientific worms. Let's just do some quick back-of-the-napkin math here. If a 60-kilogram teenager shrinks down to a 20-kilogram kid, that means 40 kilograms of stuff. We're talking bone, muscle, fat, water, all of it has just disappeared in minutes. And that's the billion-dollar question, isn't it? 40 kilograms is a lot of matter. The law of conservation of mass is like one of the most basic rules of the universe. It has to go somewhere. So what happened to it? A lot of people's minds jump straight to Einstein's famous equation, E equals mc squared. Could that mass have just turned into energy? Well, that's what we call a category error. It's like trying to use a recipe for a cake to fix a car engine. That formula applies to nuclear reactions, like in an atom bomb, not chemical reactions inside a human body. If you actually converted 40 kilograms of mass into energy, you'd get an explosion that would wipe an entire city off the map. So the real problem isn't nuclear physics. It's a straight-up biological nightmare. There is absolutely no way the human body could get rid of 40 kilograms of material in a few minutes. The process of breaking down that much tissue would create so much heat, it would literally cook the person from the inside out. All of the body's systems, circulatory, renal, you name it, they would just collapse instantly. It's not a transformation, it's a catastrophic, total system failure. So if the science is so completely, utterly impossible, why use it? Because APTX 4869 was never supposed to be realistic. It's a storytelling tool. It's a symbol for getting a second chance at life, forcing our hero to look at the world through a completely new pair of eyes. In this case, the story is way more important than the science. And that brings us perfectly into our last category, where science isn't meant to be literal at all. Instead, scientific ideas are used as these amazing metaphors to explore really deep themes about life, energy, and our place in the world. A perfect example is the LCL from Neon Genesis Evangelion. It's a liquid that fills the cockpit, and pilots can actually breathe it. This is based on real-world research into liquid breathing. But in Evangelion, the LCL becomes so much more. It's also a shock absorber, it's a neural link to the giant robot, and it's even described as the primordial soup of life. The story takes a real scientific idea and just cranks it up to 11, turning it into a profound symbol. We see the same kind of thing happening in Final Fantasy VII. In that world, everything is powered by Mako energy, which is described as the planet's own life stream, its collective life force, literally being sucked out of the ground to power civilization. And this cycle is just a brilliant planetary scale metaphor for thermodynamics. The life stream is the planet's ordered, complex, life-giving energy. The Mako reactors take that useful energy and turn it into electricity. But in doing so, they create disorder and waste. They're slowly but surely draining the planet of its ability to support life. It is the second law of thermodynamics played out as a global environmental tragedy. Okay, so we've looked at science that's plausible, science that's impossible, and science that's metaphorical. Which brings us to the big question. Why does any of this even matter? What's the point of digging into the science of fiction? Well, here's the thing. These stories are so much more than just entertainment. When you break down a space colony that actually follows the laws of physics, you get a whole new appreciation for mechanics. When you ask how a person could possibly shrink, you end up learning about biology. And when you watch a fictional planet die because of how it uses energy, you start to think about the real-world consequences of our own technology. Fictional worlds inspire us to ask, what if? And that question is the engine that drives all real scientific discovery. In the end, that's the real power here. These stories aren't just holding up a mirror to our reality. They're like a lens that helps us see our own world more clearly. They push us to question everything around us and to imagine the incredible worlds we might just build one day. So next time you see some crazy science on screen, don't just write it off. Ask yourself, what amazing truth about our world is it trying to show me?